This next lecture is on a concept that confuses a lot of people. But now that you're armed with your understanding of the execution stack, execution contexts, and variable environments, the scope chain won't be that difficult for you to understand. Let's take a look at another piece of sample code. Very similar. We have function B, function A, and the myvars again, except in function B, we're not declaring myvar. We're just going to console.log it. So what do you think is going to happen when we get to that line in function B and we console.log myvar? Remember, when B is invoked or executed or run, it creates a new execution context, puts it on the stack, and puts into its variable environment any variables that are declared. But myvar is not declared. So what do you think is going to happen? Let's put the code into our JavaScript file. Again, I'm console.logging myvar inside the B function. And here myvar is 1, here myvar is 2. I'm invoking B, console.log, and at the end I'm invoking A here, so that's where this will all start. So what do you think I'll see in the log? Let's run this. And when I look in the developer tools, in the console, I get a 1. A 1. The value that was sitting here at the global level. Is that what you expected? Some of you might have expected it to be undefined because we didn't define myvar, we didn't declare it inside this function, inside its variable environment. And maybe some of you thought it might be 2 because we called B from function A, and maybe somehow it would know what its value was there. But instead, it's 1, the value at the global level. Let's see why. So remember this. Function B, console.log myvar, was a 1, or what was sitting on the global execution context. Not undefined, not 2. Why? Well, remember, we have our execution stack. At the global level, it was 1. When A is run, we also varred myvar, and that was a value of 2. And then when B was executed, we just console.logged, and we didn't declare anything. And that was just empty. There is no myvar in that execution context variable environment. But when we request a variable, when we do something with a variable, JavaScript does more than just look in the variable environment of the currently executing context. Remember that each execution context has some special things that get created for you, like the variable this. Remember, we also mentioned one other thing that we haven't used yet, the reference to the outer environment. Every execution context has a reference to its outer environment. Now, what is its outer environment? Well, in the case of function B, its outer environment is the global execution context. And that's also the case in function A. Even though A is directly below B in the execution stack as far as what code is going to run, that little outer environment reference that each execution context gets doesn't necessarily have to be the execution context directly below it. Instead, it's something that we've already talked about. What kind of outer environment are we referring to? Remember that big word that we used almost at the beginning of this course? The lexical environment. Wait a minute. Back up. Lexical environment? Didn't that mean that where something is written physically in your code is important? That it determines certain things as far as how the JavaScript engine will decide and interpret where things live and where things will sit in memory and how they'll connect to each other? That's right. So where does function B sit lexically? it lexically sits on top of the global environment. In other words, it's not inside function A. It's sitting right there at the same level as that last line where myvar equals 1. Now, don't get lost about this. We're not changing our minds in that the execution contexts don't matter, don't regard where something is sitting physically in the code. It doesn't. The B could be above the A could be above the B. It doesn't matter. What's going to happen is the order of execution will determine how those are invoked, how those execution contexts are created. However, JavaScript does something special. It cares about the lexical environment when it comes to the outer reference that every execution context gets. And when you ask for a variable while running a line of code inside any particular execution context, if it can't find that variable, it will look at the outer reference and go look for variables there, somewhere down below it in the execution stack. And that outer reference, where that points, is going to depend on where the function sits lexically. So my B function sits lexically, not inside A, but at the global level, right smack dab at the outmost point of the code. And so its outer environment, its outer lexical environment, is global. And so is A's. In JavaScript, when I asked for myvar inside that B execution context, it couldn't find it. And so it went down and found it in the global execution context. So again, these execution contexts are created, and it doesn't matter where the code is physically written, where these functions are physically written in regards to when these execution contexts are created. That has to do with when you invoke them. But when you invoke them, when you invoke a function, the JavaScript engine creates an outer reference for that execution context, and it looks at where the code was physically sitting. The syntax parser already knows, because it went through line by line your code, and it knows where that function was written, and it then creates the appropriate outer reference based on where your function was physically written in the JavaScript file. Now, this entire act of searching, this chain of references to outer environments, because this execution context stack could get really tall, and maybe myvar is a ways down the stack. It has to search one and then look for another outer environment and search again until it gets all the way to the bottom where the global is, where there is no outer environment, to find myvar. So if I had several more functions calling each other, it would keep on moving down until it hit global, if those functions were defined inside each other, down those outer environment references until it finds it or doesn't. That whole chain is called the scope chain. Remember, scope means where can I access a variable? And the chain is those links of outer environment references, lexical, that is where it was physically written in your code. So when we said inside function B, console.log myvar, it looked for myvar, couldn't find it, and went down the scope chain. Now, it's going to go down the execution stack, but it jumps because it's not necessarily right below it. The outer environment, in this case lexically, was global. All right, let's show how we can change this by changing the lexical environment of the function. All right, so let's take a look at function B again. Where is it lexically? Well, it's lexically sitting in the global environment. Remember that this is where it sits. It's actually attached to the global object. It's declared lexically, physically, at the same spot that myvar is. It's not inside a function, it's just there on the JavaScript file. So, the JavaScript engine when it generates the execution context, when B is called, it creates that execution context and creates an outer environment along with the this variable and other things. It creates an outer environment reference to the lexical environment. That is to say, hey, the JavaScript engine saw that the function is sitting physically here, or it could also be sitting physically here, doesn't matter. It's sitting physically, though, not inside any other functions, so its outer reference is the global execution context variable environment. So when it looks for my var, it can't find it in here, so it goes down the scope chain, skips over that A execution context because it's not lexically in there, and finds it here. So when I run this code, I get a 1. But if I change the lexical environment and put function B inside function A few things happen. I've changed the lexical environment of B, meaning that I've changed where it physically sits in the code so that it's inside a function. And so its environment is different. Immediately, that means I can no longer just call B out here at the global level, because what will happen is the global execution environment will look for the function B, but that was never added to its variable environment because it's inside A. So the JavaScript engine, when it created the global execution context, it found function A and added it, but it didn't go look inside function A or anything like that. It just went to the end of function A and kept going. So there is no B in the global execution context. So I'm going to get an uncaught reference. B is not defined. See that? Because that first creation phase didn't find function B in the global execution context was created, only function A, because that's where it's sitting lexically. Function A is visible lexically, but not B. However, when I call A, did you notice what the value was? I called A. A's execution environment is created, its execution context, and when I call B, what's my var? 2. Do you see what just happened? All right, so what just happened? Well, the same execution contexts were created. A global, and then A was called, and then B was called. However, because B was sitting physically inside the A function, the JavaScript engine said, well, its outer reference will then be A, because that's where it's physically sitting. And A's would then still be the global. And so when we asked for myvar this time, when it went down the scope chain because it couldn't find it in B, instead of going to global, it went to A. Found myvar, it said, hey, you asked for myvar, and when I went to the outer lexical environment, I found myvar, and so it's 2. Make sense? The outer lexical environment of B is A this time because B is physically sitting in the physical code that we typed. It was physically sitting inside function A. So where something sits physically, thinking lexically, is a really easy way to figure out how something will be found along the scope chain. In other words, if I don't declare a variable inside a function, where will I go find it? So function B is sitting inside A. So if I don't declare it inside B, it will go look for it first inside A. If it can't find it inside A, A's outer reference is to global, and so it'll look for it there. So notice I just got rid of that. It's back to 1. See, it went up or down, depending on how you want to think about it, the chain, the scope chain. So I look for myvar in the B execution context. Can't find it. The outer reference is A. Can't find it. The outer reference of A is global. Hey, there it is. See how that works? Now, another way to think about this, if you don't want to think lexically, is who created me? The outer reference is to the execution context in which the function was created. So in this case, function B isn't created until A's execution context is created, right? Because the global is just going to add my var and A. Then when A is run, it's going to go through its create phase and say, I need to create B. And since B was created during the creation phase of A's execution context, that's its outer environment. If I moved B back out, then now when is B created? B is created when the global execution context is created. And so that's its outer reference. It's a different way of thinking about it. It still works. But the fastest way to think about it, in my opinion, is thinking about it lexically. That way you can just look at your code and know, oh, if I have code that looks like this, this is going to be a 2 because of where it sits physically, lexically. Make sense? All right, so again, if I just remove all of this, it will go all the way up the scope chain, and I still get a 1. All right, so we've learned that where a function sits determines its outer environment reference. But as it's being executed, those execution contexts are stacking up, and it's running synchronously. We've learned quite a bit, and we're understanding the scope chain. This concept can be confusing for people. It can be a little weird. But if you understand what's happening under the hood of JavaScript, you'll be able to determine what's really happening to your code. And when you have a problem, when a variable is an unexpected value, you'll be able to debug it and say, I know why it is what it is, because I know how this really works. All right, let's move on.